explain why the mean value theorem does not apply for f of x is equals to x to the power of 2 over 3 on the interval minus 1 up to 1. ይሄ ጥያቄ ምንድነው የሚለን mean value theorem ለዚህ function on this interval ለምን መጠቀም እንደማንችል explain አድርጉ ነው የሚለው ኦኬ ለዚህ function በተሰጠው interval mean value theorem apply ማናደርግበትን ሁኔታ ነግራችኋለሁ so first of all what is mean value theorem so mean value theorem states that if one thing if the function is continuous on the closed interval AB and this function f is differentiable on the open interval AB ሁለቱን እነዚህን ኮንዲሽን የሚያሟላ ፋንክሽን ካለ ምን ይለናል then there is a number c taken from the open interval AB such that the derivative at c is equals to f of b minus f of a over b minus a. ይሄንን ነው mean value theorem የሚነግረን so mean value theorem apply ለማድረግ ምን ያስፈልገናል continuous የሆነ function በዚህ closed interval continuous የሆነ function መኖር አለበት at the same time the function should be differentiable on the open interval እነዚህን ሁለቱን ነገሮች ካሟላ ምን ብሎ assume ያደርጋል mean value theorem there is a number c from the open interval satisfying the derivative of the function at c will be f of b minus f of a over b minus a. Here no mean value theorem የሚነግረን now our function is given by f of x is equals to x to the power of 2 over 3. Okay, so the derivative of this function becomes 2 over 3 times x to the power of minus 1 over 3. Okay, you can rewrite this thing as 2 over 3 times x to the power of 1 over 3. So our first derivative or the derivative of the given function becomes 2 over 3 times cubed root of x to the power of 1 over 3 ማለት cubed root of x ነው so አሁን እዚህ ዴሪቬቲቭ ውስጥ ምን ማክተት አንችልም ዜሮ ማስገባት አንችልም f derivative at 0 doesn't exist okay does not exist ለምን ዜሮን ወሰድኩኝ the interval is from -1 up to 1 በዚህ ኢንተርቫል ውስጥ ማን አለች ዜሮ አለች so f derivative at 0 ምን ይሆናል does not exist ነው የምንለው so ዜሮን እዚህ ዴሪቬቲቭ ውስጥ ማስገባት አንችልም therefore ምን ማለት እንችላለን therefore we can't use mean value theorem for the function f of x is equals to x to the power of 2 over 3 on the interval minus 1 up to 1 ኢንተርቫሉን ከቀየርነው ግን for example ኢንተርቫላችን ከ1 እስከ 2 or ከ0ን ኤክስክሉድ የሚያደርግ any ኢንተርቫልን ከተጠቀምን mean value theorem ይሰራል ማለት ነው using the mean value theorem show that the first case using the mean value theorem if this condition is given for every x taken from a certain interval then this inequality holds true for all x taken from the given interval እንግዲህ mean value theorem ተጠቅመን ይሄ ኮንዲሽን እውነት ከሆነ ይሄ inequality ሁሌም እውነት እንደሚሆን አሳዩ ነው የሚለው እንግዲህ so mean value theorem እንጠቀማለን what is given absolute value of f derivative at x is less than or equals to 1 for all x taken from a certain interval I ለማንኛውም x ከተሰጠው ኢንተርቫል ይሄ ኢኒኳሊቲ እውነት ከሆነ የተጠየቀውን ይሄንን ኢኒኳሊቲ ሁሌም እውነት እንደሆነ ማሳየት እንችላለን ማለት ነው። It's very simple. So what we need to know here is f derivative at x ማለት ምን ማለት ነው? The rate of change of f with respect to x ማለት ነው። ኦኬ በሌላ አባባል ዴሪቬቲቭ ማለት ሬት ኦፍ ቼንጅ ነው፣ ጂኦሜትሪካሊ ስሎፕ ማለት ነው። ይሄ ተሰጥቶናል። ኦኬ in place of f derivative at x you can use the instantaneous change of the function through change in x ማለት ትችላላችሁ። so change in f ማለት ምን ማለት ነው? You can take two x1 and x2 values from the interval, so f of change in x ማለት f of x1 minus f of x2 ማለት ነው። change in x ማለት you can take any x1 and x2 from the interval x1 minus x2 ይሆናል ማለት ነው። you can substitute this one in place of f derivative at x. this is less than or equals to 1 ብለናል, but we can take any x1 and x2 from the given interval. okay, so ከዚህ ምን እናገኛለን ማለት ነው? using the property of absolute value, this can be written as f of x1 minus f of x2 over absolute value of x1 minus x2 ይሆናል ማለት ነው። this is less than or equals to 1. so this implies absolute value of f of x1 minus f of x2 is less than or equals to absolute value of x1 minus x2 ይሆናል ማለት ነው። okay, therefore if f derivative at x is less than or equals to 1 for all x an element of a certain interval, then always it is true that then absolute value of f of x1 minus f of x2 is less than or equals to absolute value of x1 minus x2 እንላለን ማለት ነው። this works for every x taken from a certain interval. so mean value theorem ተጠቅመን ይሄንን እውነታ ማሳየት እንችላለን። if we understand the a part, the b part will be very simple. so ወደ b ልውሰዳችሁ። b ጋር ስንመጣ ምን አለን? absolute value of sine x is less than or equals to absolute value of x for all x an element of real number. ይሄን እውነት መሆኑን በሚን ቫልዩ ቴረም በመጠቀም ማሳየት እንችላለን። now let's say our function is sine x ፋንክሽናችን sine x ቢሆን ለምንድነው በዚህ ፋንክሽን ላይ ሚን ቫልዩ ቴረም መጠቀም የምንችለው? this function is continuous on any real number. Sine function is differentiable. okay, it's differentiable on any real number, so that we can apply mean value theorem apply ማድረግ እንችላለን ማለት ነው። so f of x አችን sin x ከሆነ የn ሪዘልት በውስጣችን እንያዝ። so ምን ማድረግ እንችላለን? f of x is equals to sin x continuous ነው on real number, differentiable ነው on real number. so a ውስጥ የሆነ ያየነው ነገር አለ። f of x sin x ከሆነ f derivative ምን ይሆናል? cos x. the derivative of sin x is cos x. so obviously absolute value of cos x or f derivative is always less than or equals to 1. always sine ሆነ cosine absolute values ብንወስድ ቫልዩአቸው ሁሌም less than or equals to 1 ነው። this works for all x an element of real number. ይሄ እውነት እንደሆነ እናውቃለን። so by the result in a ምን ብለናል? a ውስጥ if absolute value of f derivative is less than or equals to 1, then ምን ይኖረናል ብለናል? absolute value of f of x1 minus f of x2 less than or equals to absolute value of x1 minus x2 ብለናል። So you can choose x1 and ዝም ብለን arbitrary x ማድረግ እንችላለን. So this can be written as f of x minus f of 0. You can take any number because x is an element of real number. This is less than or equals to x minus 0. So f of x ያልነው ማንን ነው? እዚች ጋር sin x ነው. Okay, f of x ያልነው sin x ነው. So absolute value of sin x minus sin 0 is less than or equals to x minus 0, which is x. But sin 0 is 0. Therefore, ምን ይኖረናል ማለት ነው? Absolute value of sin x is less than or equals to absolute value of x for all x an element of real number እንላለን ማለት ነው. You see, for any real number x, this is always true. Number 28, find the asymptotes, interval of monotonicity, critical points, the local extreme points, intervals of concavity, and inflection points of the following function. እዚህ 28ኛ ጥያቄ ውስጥ ስንት ነገር ነው ያለው? ስንት ፋንክሽን ነው ያለው? 1 2 3 4 5 6 7 8 9 አይነት ፋንክሽን ተሰጥቷል። ለእያንዳንዱ ፋንክሽን ምን እንመልሳለን? አሲምቶትስ 1፣ ኢንተርቫል ኦፍ ሞኖቶኒሲቲ 2፣ ክሪቲካል ፖይንትስ 3፣ ሎካል ኤክስትሪም ፖይንትስ 4፣ ኢንተርቫል ኦፍ ኮንኬቪቲ 5፣ ኢንፍሌክሽን ፖይንትስ 6። ለዘጠኙ ጥያቄ 6 ነገር እየመለሰ እንሄዳለን። 54 ማለት ነው። ይሄ 28ኛ ጥያቄ 54 ነገር ነው የሚጠይቀን። ሶ የኤን ፓርት ታሳያችሁና ሌላውን ደግሞ ራሳችሁ ትሞክራላችሁ። መልሳችሁን ከኔ ጋር ኮምፔር ማድረግ ከፈለጋችሁ በውስጥ መስመር ታናግሩኛላችሁ። ሶ ቀጥታ አሁን ወደ ኤ ፓርት እንሄዳለን። Now let's see the first function, the function in A, which is f of x is equals to minus 3x to the power of 4 plus 4x cubed. Okay, for this function, we will try to see the asymptotes. Actually, any polynomial function has no any kind of asymptotes. So the first thing is about asymptotes. So f of x, f has no, this function has no vertical asymptotes, horizontal asymptotes, and oblique asymptotes. There are 3 asymptotes. Okay, so there is no asymptote for this function. If you want to know how an asymptote can be obtained using the limit concept, you can see question number 4 and 5. አራተኛና አምስተኛ ጥያቄን ቪዲዮ ሰርቼ ለቀኩላችሁ አለ። እሱን ማየት ትችላላችሁ። እንዴት ነው vertical asymptote and horizontal asymptote for any function calculate የሚደረገው using limit የሚለውን ሄዳችሁ ማየት ትችላላችሁ። So this is for the first part, for the function in A, this has no asymptotes at all. So እንደዚህ ብለን እናልፋለን. The next thing is interval of monotonicity. Okay, intervals of monotonicity. Okay, monotonicity or intervals of monotonicity የምንለው ፋንክሽኑ ኢንክሪዝ የሚያደርግበትና ዲክሪዝ የሚያደርግበትን ኢንተርቫል ነው። So the function f is monotonic if f is increasing or decreasing. So functionation increase ወይም decrease የሚያደርግበትን ኢንተርቫል መፈለግ ማለት ነው። intervals of monotonicity. So እንዴት ነው የምንፈልገው intervals of monotonicity? First, we take the derivative of the function. Okay, our function is minus 3x to the power of 4 plus 4x cubed, so its derivative becomes minus 12x cubed plus 12x squared. Okay, now f is increasing whenever the second derivative is, the first derivative is positive. So f is decreasing whenever the first derivative is less than or equals to 0. So የነዚህን solution መፈለግ ማለት ነው intervals of monotonicity ማለት. So first derivative greater than or equals to 0 ማለት f derivative greater than or equals to 0 implies minus 12x cubed plus 12x squared is greater than or equals to 0 ማለት ነው። ይሄ ማለት ምን ማለት ነው? በሌላ አባባል if you factor out 12x squared minus 12x squared, it becomes x minus 1 greater than or equals to 0 ነው የሚሆነው። This first derivative becomes positive for x less than or equals to 1. Okay, so this is the interval of one of the interval of monotonicity. increase የሚያደርግበት interval አንደኛው ይሄ ነው። The other things, first derivative less than or equals to 0 የሚሆንበት ነው። ያ ማለት minus 12x cubed plus 12x squared less than or equals to 0 የሚሆነው x positive x greater than or equals to 1 ሲሆን ነው። ይሄ ማለት 1 up to infinity ሲሆን ነው። So these are the intervals of monotonicity. Okay, intervals of monotonicity የምንላቸው ይሄንን ነው ማለት ነው። ይሄን interval. Next, we are going to answer critical points. So what is critical point? Okay, critical points can be obtained by solving the first derivative for 0. Okay, first derivative አችንን ለ0 solve ስናደርግ የምናገኘው result critical point ይባላል. So obviously our first derivative for the function in a, first derivative አችን minus 12x cubed plus 12x squared ነው. So first derivative ለ0 solve ማድረግ ማለት ምን ማለት ነው? minus 12x cubed plus 12x squared ለ0 solve ማድረግ ማለት ነው. So this means minus 12x squared into x minus 1 is equals to 0. This implies x is equals to 0 or x is equals to 1 ይሆናል ማለት ነው። These are critical numbers. Okay, critical numberዎችን ካገኘን በኋላ ወደ critical point መሄድ እንችላለን። So ከሎካል ኤክስትሪም ፖይንትስ ጋር የተያዘ ነገር ስላለ ወደ ሎካል ኤክስትሪም ፖይንትስ እንሄዳለን። So these are critical numbers. Okay, next we do have the local extreme points. So the local extreme points means local maximum and local minimum are the extreme points. ስለዚህ local extreme points የምንላቸው local maximum እና local minimum ፖይንቶችን ነው። So እነዚህ local minimum እና local maximum point እንዴት ነው የሚገኙት? So this local minimum and local maximum points can be obtained at the critical points. So the local extreme points can be obtained at the critical numbers. Okay, at these critical numbers. እነዚህ local maximum እና local minimum እንዴት ይገኛሉ? So the function f has a local minimum if the second derivative at the critical number is positive. Okay, the other thing, f has a local maximum if the second derivative at the critical number is negative. Okay, critical number ዎቻችንን ወስደን እናስገባለን second derivative ውስጥ then local minimum እና local maximum እናገኛለን። second derivative at the critical number 0 ከሆነ ግን inflection point ነው የሚሆነው. So where is our second derivative? This is our first derivative. So the second derivative for our function is minus 36 x square plus 24x ነው የሚሆነው። ኦኬ እዚህ ውስጥ ምን እናስገባለን? ክሪቲካል ነምበርን እናስገባለን። ሰከንድ ዴሪቬቲቭ ውስጥ የመጀመሪያው ክሪቲካል ነምበር 0 ነው። 0 ስታስገቡ እዚህ ውስጥ ሰከንድ ዴሪቬቲቭ 0 ነው የሚሆነው። ሶ ሎካል ማክሲመምም ሎካል ሚኒመምም አናገኝም። አት 0 ኢንፍሌክሽን ፖይንት ነው የምናገኘው፣ እሱን እንመጣበታለን። ሌላኛው ክሪቲካል ነምበር ከ0 በኋላ ያለን 1 ነው። 1ን ሰብስቲዩት ስናደርግ ኢን ደ ሰከንድ ዴሪቬቲቭ እዚህ ሰከንድ ዴሪቬቲቭ ውስጥ 1ን ሰብስቲዩት ስናደርግ የምናገኘው ሪዛልት ማይነስ 12 ነው, which is a negative number. So now we can have local maximum. So at 1 we will have local maximum. ስለዚህ ፋንክሽን ውስጥ 1ን እንከታለን። ኦኬ 1ን እንከታለን። the result is 1,1 is local maximum. So for this function we don't have local minimum. Okay, local maximum አለን, local minimum ግን የለንም ማለት ነው። So the next one is interval of concavity. Okay, interval of concavity የምንለው interval of concavity classify ይደረጋል። The function may be concave up or concave down. Okay, concave down. So algebraically the function becomes concave up in the interval where the second derivative is greater than or equals to 0, and it becomes concave down where the second derivative is less than or equals to 0. So now our second derivative is here, so let us write our second derivative. So our second derivative is minus 36 x squared plus 24x. This is our second derivative. So it becomes concave up whenever it is greater than or equals to 0, which means minus 36 x squared plus 24x is greater than or equals to 0. Here we are just calculating the interval of concave up, so we can factor out some numbers. So if you factor out some number, maybe minus 12x, it becomes inside it becomes 3x minus 2 is greater than or equals to 0. So to find the solution for this part, you can use case method or sine chart method. For me, I prefer to use line. So the boundary points are 0 and 2/3, and the leading coefficient is negative, so I start from left to right, from negative plus minus. So the second derivative becomes positive in this interval. Okay, that means from 0 up to 2/3. ቼክ ማድረግ ትችላላችሁ ኬዝ ሜተድ ኦር ሳይን ቻርት ሜተድ ተጠቅማችሁ። ይሄኛው ሜተድ ምንድነው የሚለ ያ ለተማሪ ካለ ይሄ ሜተድ ማወቅ የሚፈልግ ካለ ለብቻ ቪዲዮ ሰርቼ ለቀላችኋለሁ። ኤኒዌይስ 0 up to 2/3 the function becomes concave up. Okay, then in the rest of the intervals ከ2/3 እስከ ፖዚቲቭ ኢንፊኒቲ እና ከ0 እስከ ኔጌቲቭ ኢንፊኒቲ ሰከንድ ዴሪቬቲቫችን ኔጌቲቭ ይሆናል። So in this interval from negative infinity up to 0 union 2/3 up to positive infinity, the function becomes concave down. Okay, this is how we can respond about concavity. And lastly, we do have inflection point. Okay, the last one is inflection point. Okay, inflection points can be obtained by solving the second derivative for 0. Okay, our second derivative is already here. Okay, this is our second derivative. Solve this second derivative for 0. Minus 36x squared plus 24x is equals to 0. So factor out minus 12x, then it becomes 3x minus 2 is equals to 0. So the solution for this becomes x is equals to 0 or x is equals to 2 over 3. Okay, these are the points that gives us inflection points. So whenever x is 0, the function becomes 0. Whenever x is 2 over 3, you can substitute 2 over 3 in the function. So these are the inflection points, or you can say 0, 0 and 2 over 3 comma 16 over 27. 16 over 27. These are the inflection points. Okay, these are the inflection points. እንደዚህ ያላችሁ ነው ለሌሎቹም ፋንክሽን እየሰራችሁ የምትሄዱት።